Hi all. In this lecture, we will be discussing on the design considerations for a good lighting scheme and also on the different laws of illumination. So the first point is on the intensity of illumination, and that we generally say in terms of illuminance. So the value of the illuminance will be depending upon the type of work and also on the place of the work. So whether you are inside a living room, how much amount of lux level it is required, and similarly, if you are doing your job in your office, what should be the amount of illuminance, and if you are walking through a corridor, what should be the value of the illuminance. So depending upon the usage and depending upon the place, the value of the illuminance will be varying. And general values of illuminance for different places and types of work is being referred in the handbook by M.K. Giridharan. You can refer to the table 4, 5, 6, 7 and 8. Next one is a selection of lamp or selection of luminaires. So there the one thing which comes into picture is nothing but the quality and the quantity of the lighting. Okay, so depending upon the application, it will differ. What type of lamp, what type of luminaire we need to select will be changing depending upon the type of application. So generally the fluorescent lamps and LED lamps are used when the lighting is needed in a very small areas, that is in our work, office, home, like that we'll be using that kind of lamps. But in very large areas, the lighting is being provided by high intensity discharge lamps, like a mercury vapor lamp or a sodium vapor lamp. And depending upon the illumination which is required, whether you need a direct illumination, whether you need an indirect, or whether you need a semi-direct or semi-indirect, the type of the luminaire will be changing. So the quality, the quantity, then the direction of lighting, then the choice of application, all will be taken into consideration while selecting the lamp and the luminaire. Next is size of the room. So not all the lumen output or the light output from the lamp will not be reaching to the work plane. So that we have already discussed in the previous lectures, some amount will be reflected, some to the wall, to the ceiling and to the floor, and only a portion of the light output from the lamp will be coming onto the work area or the workplace. So a part of the light is being lost in the fittings, then also to the walls and the ceilings. So this is taken into account by the coefficient of utilization or CU. This is nothing but the ratio of the lumens reaching the work plane to the total lumens given out by the lamps. And that is known as the coefficient of utilization or the utilization factor. So this we have also discussed on the various factors which are going to affect the coefficient of utilization in our previous lectures. Next is the mounting height and the spacing of the fitting. So it will be again depending upon the type of the building and type of the lighting scheme which you have chosen. The distance of the light source from the wall should be equal to half of the distance between the two adjacent light sources, and the distance between the light fitting should not exceed 1.5 times the mounting height. So the mounting height is nothing but so this is your room and this is the total height of your room, and this is your work plane, and this is where your luminaire is fixed. So mounting height is nothing but from the bottom of the luminaire to the work plane. So this is nothing but their mounting height HM. So the building will be used for different types of purposes. So conditions of use is another design aspect, and whether it is a air conditioned room, whether it is a corridor, whether it is a go down. So depending upon that, the type of application, the lighting design will also vary. So if the dust and dust particles are more, then the amount of lumen output from the lamp will be reducing at a faster rate. So therefore you need to consider the factor known as the light loss factor, which you had discussed in the earlier sessions. And this light loss factor is also known as the maintenance factor. So again, there are various factors which comes into account when we are looking at the light loss factor, that is the recoverable light losses and the non-recoverable light losses. Next we are going to discuss on the laws of illumination. there are two laws of illumination, that is, one is known as the inverse square law and the second one is known as the cosine law. And these two laws are applicable to point sources. So it is not being considered for a very large lumina which is having a high diffused areas. You can just consider it as an incandescent lamp or a small LED lamp. You can consider it as a point sources. So first we will be discussing on the inverse square law. So it just states that the illumination E or the luminance E of a source is directly proportional to the luminous intensity and inversely proportional to the square of the distance between the source and the illuminated surface. So it is E is equal to I divided by D square, where I is the luminous intensity and E is the illumination of the surface, and that unit is lux. And D is the distance between the source and surface to be illuminated, that is in meters. And this inverse square law is applicable when the system is normal to the direction of the light beam. When the system is normal to the direction of the light beam, then you can use this inverse square law. That is, you have your light source, you have your plane of work, and this is nothing but your distance d. And the luminance intensity given by the lamp is I. So here I can say that E is equal to I divided by D square. So the inverse square law is applicable when we are considering the light from the source is normal to the plane. That is this one. So it is normal to the plane. And there are certain times when we need to consider you have your light source which is providing the light output, and you need to also calculate what is the luminance which is occurring at this particular area. So under such conditions we cannot apply inverse square law. There we need to apply the cosine law. So when the plane to be illuminated is not normal to the direction of the luminous flux and is inclined by an angle theta, then we will be using the cosine law. So this law states that the illumination of surface is proportional to the cosine of the angle between the normal to the surface and the line of flux. So E is again inversely proportional to the d square, which we have already seen from the previous law, and here we will be considering it as I cos theta by d square. So how we will be getting this cos theta we will be discussing in the next slide. So our two laws are, when the source is directly above the point, it is illuminance E is nothing but I by d square. So in that case, you have your point source, you have your work plane, and this you are measuring it as d. And when the light arrives at a point on a horizontal surface at an angle, say this angle is nothing but the angle theta, then you need to apply the cosine law. So I is nothing but the luminous intensity. I is nothing but the luminous intensity which is going in this direction, and it has two components. One is the horizontal component and another one is the vertical component. So you are looking at the vertical component, and that means this is the angle theta, and therefore this one will be I cos theta. So therefore I cos theta divided by d square, you will be getting the illuminance, that is nothing but using the cosine law. Now we will just do a simple problem. So here it is mentioned that a point source produces 3000 candela. Candela is a unit of the luminous intensity, and the angle of incidence with respect to the vertical is 30 degree. So that means this angle is 30 degree. 30 degree. And therefore you are asked to find out the illuminance at a point 5 meter away from the light source. So this length is nothing but 5 meter. So it is I cos theta divided by d square, which is 3000 into cos 30 divided by 5 square. So you will be getting it as 103.92 lux. So here always do remember that this d is nothing but this distance, and this h is nothing but the height at which it is being mounted. So h and d will be equal when you are applying the E is equal to I by D square formula. So in this case, this 5 meter is nothing but from the point source to the region at which you are going to find out the value of your illuminance. Now we will just go through the lighting handbook. What are the values which you have mentioned in the handbook regarding the illuminance and the tables which you need to use for your lighting design calculation. So this is your lighting design handbook by M.K. Giridharan. From page number 3 onwards, it is with your lighting design procedures. Basically, there are 3 procedures are there, and we will be mainly discussing on the longhand method, and each step by step it is mentioned over here. And this is what we were discussing when we were discussing about the design aspects. So the recommended levels of illumination for domestic buildings, the unit is in the lux. So the living room, it should be 300 lux. The dining room, it should be 150 lux. The bedroom, kitchen, bathroom, workshop, study room, it should be 300 lux. So these are being taken from the National Electric Code. And this is again depending upon the type of location, and also in the cinema halls, theaters. Then for the school or building. So it depends upon the type of work and the type of building, it will be changing the illuminance value. Again for the hospital buildings, again for the office buildings. So if the illumination level is not given in your question, then you need to select the value of illumination from this table depending upon the type of application. Also the different ratings of the lamps and the lumen output is also given. And this is again required if in your question, if only wattage is given, or then you need to consider the lumen output from this particular table. Different types of lamp, what are the illumination values? This is again a comparison of light sources. Incandescent lamp, mercury vapor lamp, sodium vapor lamp, compact fluorescent lamp, the efficiency, burning hours, restart time. Just a comparison of the light sources. And this is not important to us, but this table is more important to us. This is used for the lighting calculation, where we will be discussing as table number 17 means this one in page number 12. And here one thing you need to consider, this is not room cavity ratio, this is just the cavity ratio. And this base reflectances percent, it can be ceiling reflectance percentage, or it can be floor reflectance percentage. Okay, so in both cases you need to use hand in hand. So that value is 90, 80, 70, 60, 50, and again continuing from 40, 30, 20 and 10. So that's all with our discussion. And the next session we will be discussing on the complete lecture on how we can design a lighting scheme for a particular room using these design aspects and the design table which you are seeing it now. Okay, thank you.